Thank you. Thank you. Sure. It's over here. My guys that just came in, we are finishing the worksheet from yesterday. Yes. I do have a video link. Two video links I will post. I recorded yesterday's lesson in here, and I will do that again so you can get the rest of that worksheet. Jacoy and Takori, I'm marking you tardy. I'm assuming they'll change your absence to excused tardy. But I don't have a button for that, okay? All right, we're going to go ahead and get started. You should have 1 through 8, except for number 4 from yesterday, and we're going to start with number 9. This is part of Maria's phone bill. So you look at the dates. Everybody look at the phone bill. Look at the date, the time she was on the phone, and how much it cost her. So everybody look at the chart there. And then they give us some options. They ask us to tell them which of these statements best describes the phone company's rate. So, looking at them, the very first line says that she talks for 10 minutes and it costs her 32 cents. So A is 5 cents per minute. Well, if she talks for 10 minutes at 5 cents per minute, that would be a 50-cent charge, right? So it can't be A. Would we agree? All right. B says 3.2 cents per minute. You look at that first charge. If she talks for 10 minutes, they charge her 32 cents. 32 cents divided by 10 would be 3.2 cents per minute. But look down to the next line. The next line, it says she talks for 3 minutes, and they charge her 11 cents. So 3 times 3.2 would be 9.6 cents, right? So that can't be right. Will we agree? Let's go down to that third one. So what did they charge her for 1 minute? 1 minute, there was no argument. They charged her 5 cents for that first minute, right? So 1 minute would be the first minute. So we can already rule out A and B. We know it can't be those. So is it this one or is it this one? We already know it's 5 cents a minute. We just need to know how much it's going to increase. Oh, wait. Oh, I was going to email you about that. All right, thank you. Appreciate it. I haven't had to tell you yet, but I will. Okay. So here's the question. There's a couple ways to do this. I'm going to give you the formula. We're going to do it that way. It's also, you could just think about it logically as well. But we're going to use the formula because that's what we learned using here. So if we want to know how much it increased from 1 minute to the next after the first minute, that's really just the slope, or the rate of change, right? We typically call it a rate of change in a real world problem, but really it's just the slope. Anybody remember what the slope formula is? So you are going to have a reference sheet that has some formulas on it, but this is not one that will be on there. You have to know the slope formula is the y-coordinate minus the y-coordinate divided by the x-coordinate minus the x-coordinate. And this x-coordinate has to go with this y. This x-coordinate has to go with this y, right? Ordered pairs are x and y. Input, output. So here the input is the minute. So you're writing everything I'm writing, whether it's on the worksheet or whether it's on your own paper. Definitely write input is the number of minutes she spoke, and the output is what they charge her. So on in a linear equation, linear function, we can pick any two of these ordered pairs. So I'm going to pick these two easy ones, the smaller numbers. So the ordered pair there is going to be 1 and 5 cents, and the other one is 3 and 11 cents. Okay? When she spoke for 1 minute, it cost 5 cents. When she spoke for 3 minutes, it cost 11 cents. So if we use this formula, I'm going to do the biggest Y minus the smallest. It doesn't really matter, but I'm avoiding negatives if possible. So since I put 11 cents first, I have to put the x coordinate that goes with it underneath it, and then the x coordinate that goes with the y coordinate here. So that would be 6 cents divided by 2, which would be 3 cents per rate of 1 minute change, right? So it's 3 cents per minute. Does that make sense? All right. Number 10. Arnold collects stamps and coins. Number of coins he has is 3 more than half the number of stamps. If he has 51 stamps and coins together, how many stamps and coins does he have? They're asking us to find the value of two things that we don't know. We have to find the value of two variables. There's only one way we learn how to find the value of two variables, and that's using the system of equations. So that's what we're using here. So for number 10, we're going to use the system of equations. So a system of equations is two equations with the same variables, right? We know what our variables are going to be here. How many stamps and how many coins. So let's make it easier on ourselves and use S for stamps and C for coins. So not just for stamps or coins, it has to be how many or the number of stamps. The number of coins. So based on what they've given us here, we can write two equations. Basically, this is a translating from words to algebraic equations or algebraic expressions. Once again, the number of coins he has is 3 more than half the number of stamps. If he has 51 stamps and coins all together, how many stamps and coins does he have? So let's start with this one. This one is probably the easiest one to write. What does all together mean? Combine them. What's the operation for combining? Adding. Yeah. So we're going to add. When we add them, what are they going to equal? 51. What are we adding? Right. S and C. The number of stamps plus the number of coins all together is 51. So that's our first equation, and very often that first one is really simple like that. Remember that has and is, those typically also represent, you could just write an equal sign there. So all together has would be equal 51. So we need an equal sign here. We're going to use our S and our C. But now we're looking at this sentence. The number of coins he has is, so what are we using for the number of coins? C, right? So this says C is, so actually I don't want to write it that way. I'm going to write C equals. That sentence says C equals. What is it equal? 3 more than. 3 more than something. If I have 3 more than, what's the operation I'm going to do? Use addition. So we're going to add 3 to something. What am I adding 3 to? Half the number of stamps. How would I write half the number of stamps? Say it again. 1/2 what? S, that's right. 1/2 S. So the number of coins is 1/2 the number of stamps plus 3 or 3 more than and 1/2 the number of stamps. Okay? So now, we still don't know how to, we can't just solve one of these equations. We have to use these two equations together. We learned how to solve system of equations by substitution and elimination. Also by graphing. Graphing is never a good option unless they give you the system graph already and you can just find it on the graph. And then that's a great way to find the answer or the solution to a system. But here that's not what they do. So we are going to use substitution because one of our equations is already solved for a variable. So we know that C, the number of coins, is the same as this expression. So up here in this first equation, if I replace C with this expression, now I have an equation that has all S's. And that's what we want to do. So we're going to take S plus C, but instead of C, we're using this form, 1/2 S plus 3, and it still equals 51. Because remember, this is the same as this. Now we solve this equation. Typically, everybody wants me to get rid of this fraction, so let's get rid of the fraction. What can I multiply this whole equation by to get rid of the fraction? What is the fraction in the equation? 1/2. What's the denominator of that fraction? 2. So if I multiply everything by 2, I get rid of that fraction. So 2 times S plus 2 times 1/2 S. Remember to run your calculator. 2 times 1 ABC 2, and you'll find that that's 1S. Plus 2 times 3. I know some of you don't like to write these little lines, but these will help you remember, make sure that you multiply everything by that number and 102. Combine our like terms. 3S plus 6 equals 102. 3S. What operation is being represented by 3S? Add, subtract, multiply, or divide? Multiply, right? So 3 times S plus 6. So I'm undoing multiplication, I'm undoing addition, we're going to undo the addition first. We undo addition by subtracting, we have 3S equals 96. We undo the multiplication by dividing. And so now we know that S equals 32, which means the number of coins is 32. They ask you to find the number of coins and stamps, but looking at a multiple choice selection, this is the only one that has 32 stamps. But to make sure that it didn't mess something up, I think that S is 32. 32 plus 19 is 51, so I'm feeling pretty confident that that would be my solution. If it was a short answer, we had to write the number of stamps and write the number of coins. To find the number of coins, you just go back up to this equation and plug in 32 for S and 12 for C. Same thing. All right, and the last one on this worksheet from yesterday, number 11. This is a translating from verbal to algebraic expressions, or you're actually going to write an equation. It's not a system of equations. Okay? So go ahead and read that to yourself real quick. Read number 11 to yourself. Does it sound like a lot, Swan? It does. I think you're going to be surprised at how not hard it is, though. If you always start by picking what your variable can represent, it makes your life a lot easier. Typically, your variable is going to represent what they're asking you to look for in the question. Okay? Randy's thinking of a number. When he adds 7 to the number, multiplies the sum by 3, and subtracts 2, the result is 13. What is the original number? So we're going to use X for the original number. And then we can just follow along. He adds 7 to the number. So X is the number, 3. This is a little tricky part. What do I have to do to multiply the sum by 3? Say it again? Yes. If I want to multiply the entire sum, I have to put parentheses here. So multiplying the sum by 3 means I put parentheses around the sum, and this is the 3 on the outside. And then it says subtract 2. And then it says the result is, remember, has, usually is going to be equal 13. Seems a lot harder than it is. You just don't let it overwhelm you. And now let's distribute. And combine our like terms. Now we're undoing multiplication and addition again. Let's undo our addition first. Undo multiplication by dividing. And you see that x is negative 2. And we're going to check it. So we're supposed to add 7 to the number. Then we're supposed to take that number and multiply by 3. Then we're supposed to take that value and subtract 2. What was it supposed to equal? 13. What does it equal? 13. You can also kind of work this one backwards. It's a work backward method as well, but I think this is the easier way. Once again, there's more than one way to do almost all of these problems. Okay, so make sure you've got everything written. If you're not sure if you wrote everything yesterday, you want to hold on to it and watch the video tonight and make sure you can do that. But once you're sure, staple your work to the back of that worksheet, make sure your name is on the worksheet, and put it in the basket. And then we are going to get started on number 12. Work as much of that as we can today in class, and then we'll finish it tomorrow.